you see there are three things here, right? Three things. I mean, in terms of things involved in multiplying and dividing, right? So you have a 3 here, 2 to the nth power here, and n here. 3 doesn't change at all. Is that right? N grows. So you want to, in going from one term to the next, n becomes n plus 1. N is a monomial and therefore a polynomial. Is that right? So neighboring term ratio stabilizes to what? 1. Is that right? Okay? But there's another guy, 2 to the nth power. In going from 2 to the nth power to 2 to the n plus 1 power, what happened?
Grows.
Factor of 2, right? It grows by a factor of 2. And that occurs in the what? Denominator. And therefore, I'm going to use what test? What do you think I'm going to use? I'm going to use ratio test. Because by this analysis, I notice, and you work out the detail, limits, what I was trying to convince you is that by just, once you're experienced to look at this, you see that from one term to the next, you try to appreciate what is it, what happens in going from one term to the next. What is that ratio? Ratio next one to this, right? They will see that both have the 3, so that doesn't change. This one at n, it grows slightly, n plus 1 versus n, but that ratio is stabilizing to 1, right? But 2 to the nth power, in going from one to the next, is an extra factor of 2. Is that right? So therefore, the next term will extra factor at 2 in the denominator, and therefore this ratio stabilizes to what? 1 over 2, which is less than 1. And therefore it's what? Absolutely convergence because of what test? Ratio test. All right? Okay? All right, so, this one I'll compare with 1 over n square root n. You just notice that sine square n over n square root n is less than what? 1 over, is less than or equal to 1 over n square root n. But summation 1 over n square root n converges. Why?
It's a P series, right?
Because of P series with P equal to 3 halves. Right, 1 and 1 half, 3 halves. So, summation sine square n over n root n also what? Converges. It's a positive series anyway. Is that right? So convergence, that is what? Absolute convergence. By what? Comparison test. This one is convergent. What kind of convergence? Conditional or absolute? Conditional. And why is it convergent in I'm writing nonsense. I mean it's convergence. And I ask whether it is conditionally convergent after that. I mean conditional convergence. Conditional convergence. And why is convergent anyway? What would you cite? Huh? No? In order to show that it is convergent, notice that it is alternating series. Is that right? The absolute part actually is decreasing and approaches 0. Right? Are you with me? The absolute value is 1 over square root n. 1 over square root n is decreasing, positive decreasing, and it approaches 0. Right? And then if you let it alternate, then what happens? It converges. So it converges by what test? Alternating series test. It's an alternating series whose absolute part is positive, of course, and it's what? Decreasing convergent to 0. this kind of alternating series always converges. And therefore, this series converges. But why is it only conditionally convergent? You
It
know,
has to be absolute.
that is because if you wipe out the sign, you get a p series with p equal to 1/2. That diverges. And therefore, the absolute value series diverges, which means that the original series would not qualify as a series that diverges absolutely. It doesn't converges absolutely. It doesn't converge absolutely, but it does converge, however, and that's why it's called conditional convergence. So it converges conditionally. All right. I ran out of time, so I don't have the time for that amusing fact. May I just say something? All right. Read the book. And then there's this thing. Riemann's theorem. Riemann's results. It's very amusing. A conditionally if summation an is convergent conditionally, then guess what? You know, it's converged, for example, it converges to 4, for example, right? Then guess what? Give me any number. Give me any number. 8. Right? Right? Then for any given real number, okay? Call it L. All right. Call it L. We can guess what? Rearrange the terms. There are infinite many terms. You can rearrange them in a certain way to create a new series. Okay? That's, guess what? Conditionally converges to that number that you randomly pick. Did you say 8? Right? Then Riemann said, I guarantee you, if you do it properly, you can take that original series, which is conditionally convergent, which means it doesn't converge absolutely, of course, right? And then in that case, it's guaranteed. Riemann said you'll be able to rearrange it in a certain way to manufacture a new conditionally convergent series, which converges to what? That number, 8. And you say, well, how about -5? Riemann can manage that. All right. So very counterintuitive, but it's true. However, if the series is absolutely convergent, then sorry, no matter what you do, no matter how you rearrange it, it doesn't change. All right. So conditionally convergent is something different.